Difference of squares is one of the more simple factoring methods. It only works when you have a binomial. The sign in the middle has to be a minus sign, and both the first term and the second term have to be squares. Here we have x squared minus y squared. Both x squared and y squared are squares, and it is a subtraction. So this can be factored with difference of squares. What we do is we write two pairs of brackets, because the answer to a difference of squares factoring will always be two binomials being multiplied by each other. The square root of the first term goes in the first position in both brackets. The square root of the second term goes in the second position in both brackets. And one bracket gets a minus sign, the other gets a plus. We can prove that this factoring works by verifying we multiply the two binomials we got by each other, and we see if it gives us x squared minus y squared as an answer. Using the FOIL, x times x is x squared. X times y is plus xy. Negative y times x is minus xy. And negative y times y is minus y squared. Since the plus xy minus xy in the middle will cancel each other out, we end up with x squared minus y squared, and that's what we started with. The difference of squares factoring method works. Let's try it with this one. We write our two pairs of brackets. The square root of 36a squared is 6a. The square root of 1 is 1. And we put a minus and a plus. Does it matter which one we put first? Here we put the minus first and the plus after. No, it does not matter. We can put the plus first and the minus after if we want. It just matters that one of them is a plus and the other is a minus. In this example, the square root of 4b squared is 2b. The square root of 9c squared is 3c. I put one minus and one plus and finished. Here we have x to the 4 minus y squared. X to the 4 is a square because any variable with an even numbered exponent is a square. The square root of x to the 4 is x squared. The square root of y squared is y. We put our minus and our plus, and we're finished. This might look like it's still factorable because we see it as a binomial, it's a subtraction, a difference, and we see that x squared is a square, but no, we cannot factor it with the difference of squares method because y is not a square. Here we have a couple of very weird looking examples.